Yaskawa.
You're watching the PLCopen Basics video tutorial series. This video shows how to use the PLCopen Toolbox user library. Hi, I'm Matt Pelletier. There are quite a few function blocks available in the PLCopen Toolbox, so there's not enough time for us to go through them all, but we do want to give you some programming experience with the basic blocks that the engineers here at Yaskawa use, including the Axis Struct data type, the Axis control function block, jog, and ReadAxisParameters. Now, the first thing I want to go over is where we're going to go here with class project number 2. We're going to start a second class project. We're not going to use the one that we've been using up to this point, but I'll have you guys copy over the positioning POU and the stop POU, and we're going to make a new servo on in the control POU. We'll have a monitor program, gearing. We'll do some gearing and homing, and a manual operation mode. HMI already exists in that initial template, which is the same template that we'll use to generate this second program. So here's a list of what we need to do. We'll back up the existing project, and then use that same class template project to create a new project. And we'll have to do like we did at the beginning, adjust our IP address. We won't have to do anything with the hardware configuration because that stayed the same. And then open up that original backed up project in another instance of MotionWorks IEC and paste those two POUs, positioning and stop, from the original into the new one. And then insert some program instances for those two. So let's do that here. I have my original project that we've been working on. And like we've done before, we'll do file, save project as, zip project as. I'll just call this one training backup. Now, once again, we need to unzip the project that's part of this training package. And that original project from the training download package may be in your download folder. So you can unzip it. And as we mentioned before, you might want to unzip it instead to your projects folder. That's always under C, users, public documents, MotionWorks IEC3, projects. And I do already have this from the original project, but I'll just save over it and replace it because we've backed up the project as the name backup. So yes, that's okay. You don't have to overwrite the toolboxes. And so here's the PLCopen starting template project for this class. Next was to update the IP address. You can go here to your resource settings and type in your IP address. Now, you've not made any changes to the online hardware configuration, so you should be able to leave that alone. But now it says open the original project in another instance of MotionWorks IEC. So just go to start another MotionWorks IEC. It'll tell you can't communicate and you got restricted, but you can file open and open that training backup that we just created. And I wanted you to copy stop and positioning. You can do copy, or you can put it off to the side like this. Just take stop and positioning and put this over here to your logical POUs folder, and that'll copy and paste it right in there. If you want it to run, you'll have to manually make it run. So we'll add positioning here, insert that program instance. And we'll add stop down here to the slow task. I think I'll put it underneath. Program instance, stop, stop. Okay. And now the class project is ready and we can begin to program with PLCopen Toolbox after a successful make. Make was successful. Okay, the first feature of the PLCopen Toolbox is there's a structure called Axis Struct. And so each of our Axis variables, instead of being called an Axis ref, let's change it to an Axis Struct. An Axis Struct has the Axis ref element in it. It's a structure within a structure. And then you'll see all of the different elements of this structure that are very useful. Okay, so if you would follow along with me here in the code, in the global variables list, go to the screw group, and for the screw variable, instead of AxisRef, we'll use AxisStruct. And under the View menu, you can view the multi-element variable window. I'll adjust that size here. And when that's updated, you can click off of it, AxisStruct, and click on the ref here and add the axis num as number 1. Right, if you're getting this red highlight like I'm getting, you can delete this initial value code, and that will fix it up. So the axis ref axis num element is a 1, and you can see the other items that are in here, such as jog speed, run speed. This way, each of your axes has this structure, so there's some semblance of order. There's even places here for feedback parameters. We'll be using that later. There's a place here for homing parameters. We'll be using that one also. And others for latch and cam. So for now, we've just moved a number 1 into the axis num. And let's do the same thing for the rotary. There's a rotary axis ref. And we'll change that to an axis struct. You click off of it. You can delete this initial value text here and expand the ref. This was axis number 2 or 27 if you're using the MP2600 IEC single axis. And now likewise with the virtual, again axis struct, and the axis num for virtual was 26, and we had one more which was axis number 21, the external encoder, axis struct. And we'll delete that one and give it a number 21. You know, I did a couple of these wrong here. Hit a comment. It's a common mistake. You get the description out. It should have been number 2. If you do it right, you see the code. Okay, apologize for that. You should see the code. I think I did the first 2 incorrectly. So let me fix that here. Initial value for the axis ref, not the description, the initial value. It's 1, and it makes this little code here. Okay. Now there's a difference when we're programming with this axis struct data type, because the axis ref element is now one element within the axis struct itself. So what that means is that we will have to put screw.ref instead of just screw like we did before. We want the ref element out of this structure. So in your existing code, such as positioning, anywhere you see a screw, you have to put now screw.ref. Problem is, when you try to compile this, you're going to get errors saying there's no matching global variable found. And what doesn't match is the data type. It says that screw is an axis ref. So you could go through these one by one and change all these to axis struct. The quicker way is to right-click on the instance of that program and click Update External Variables from Globals. And that is a little shortcut here to change all of those descriptions. So we'll need that one for positioning and for stop. Update externals from globals. And now when you make, it will make. Now you still have to go through and do screw.ref and rotary.ref so that it knows to look in the correct element. So just update those few here real quick. You could also do a search and replace, but there's not that many. So we'll just do them here manually. There, I think I got them all. And we can make this. Oh, I didn't do the stop POU. Let's do the stop POU. Screw dot R for ref, down arrow, enter, enter. rotary dot R, enter, enter, virtual dot R, down arrow, enter, enter. Not that bad. And now this program will make. So we've got the axis variant out copied from our code. So now we have not only the HMI POU like we had before, but we've copied and adjusted the stop and positioning POU, so we can use those again if we want to. But now to turn on the servo and monitor alarms, we're going to make another POU called control, running in the slow task. So please follow along to do that here with me. We'll make a new program called control with ladder diagram language. Run it in the slow task. Got the program instance here called control. And now open the control POU. And the block of interest here is the axis control block. We'll be giving it screw.ref and rotary.ref. And we can use those same global variables to enable and clear alarms. And it's all within this one block. Also, the block gives us axis alarms and warnings and ID codes for all of the possible alarms. Additionally, the structure has preset elements to store each of these outputs. So let me give you this here as a programming challenge to get the screw, the rotary, and the virtual once again enabled and alarm clear functionality using the axis control function block from PLCopen Toolbox. Here's my solution for axis control. PLCopen Toolbox has axis control. We'll drop it in there. And we've got the screw.r down, enter, enter, screw.ref. Enable will be G underscore enable screw. We'll leave enable positive and enable negative disconnected. And we got G reset screw. We've got the screw status. Screw.s down arrow, enter, enter status. You can left and down. Screw.a for alarm, down arrow to it. Next one here, drive warning, is a screw.w for warning, down arrow, enter, enter. Drive warning ID, screw.drive warning ID. Drive alarm ID, screw.d for drive alarm ID. Got those right here. And then control alarm ID, we got screw.control alarm ID. And we'll just go through, do the same thing for axis control for the rotary.ref. Gotta remember to put in those .refs now. I know it's been a while doing it without that. Got enable, G enable rotary, and G reset rotary. And the same thing here. Rotary.status, rotary.alarm, rotary.warning, rotary.drive warning, rotary.drive alarm ID, and rotary.control alarm ID. And one more, axis control for the virtual.ref. We got G enable virtual, G reset virtual, virtual.status, virtual.alarm, virtual.warning, virtual.drive warning, virtual.drive alarm, virtual.control alarm. Okay, now I know this could be tedious if you had, let's say, 60 axes, and so I can see how you may want to use a search and replace maybe have an axis N, and then search and replace that axis N text with whatever the names of your axes are. Could save some time there. Let's see if we can make and download this one. I need to get connected to my CCamilla link manager. All right, let's log in and find that camera. Log into that camera. There's my demo. And now, download. Stop it. Download she goes. And here's a cold start now. All right, now I'm all set up in debug mode to see if I can enable this. We'll toggle the Boolean here. Got that screw to turn on. And we'll turn on the rotary. We got those enabled. You can see the status here also. Looks like I've got no alarms. And that is success. If you have any errors, you can troubleshoot those with the help. And just like you did in the PLCopen blocks, you can use this error description. This should all look very familiar. The next programming challenge we'll have here is a jog capability. We're going to call that the manual POU running in the slow task. And then I'd like you to see if you can implement jog for both the screw and the virtual axis using the jog speed elements and the acceleration and deceleration elements of that structure. And here are some suggested initial values here, 180 for the speed and 3600 for the acceleration. So this is your programming challenge, and I will show how I did it here after the break. So I'll create the manual POU. Manual, sticking with ladder. So we'll put it in the slow task. Program instance, manual. All right, check that out, manual. Looks like these are kind of out of order here. I think we want to HMI and then stop. Probably servo on and then manual control last. Now the manual POU, we wanted to put the jog block first for the screw.ref axis. We've got some global variables coming from the HMI called G jog screw forward and G jog screw reverse. For velocity, we'll use screw.jog speed. Getting familiar here with the elements of that. And screw.acceleration. And screw.deceleration. Put another jog here for the virtual.ref. G jog virtual forward. And G jog virtual reverse. The velocity is virtual.jog speed. Virtual.acceleration. Virtual.deceleration. But now before we download it, we should give some values to these speeds and accelerations. And you can do that through the global variables, like we did before, by viewing the initialize multi-element variable window. I've got the screw. There's jog speed. Make sure you type in the right column here. We have 180.0 for the speed. Acceleration, we wanted 3600.0 and 3600.0. To the virtual, we're not doing the rotary. Do the same speeds here. 180.0. Acceleration, 36.0. Still, if you don't put in the decimal point, it's the wrong data type. So you'll do need 3600.0, 3600.0. And download changes. Go to debug mode. And now I can go down to jog screw forward. Let's see if this works. My jog speed is 0. So although I gave it an initial value, So you'll get an error here if I try this. Getting the error 4659. Just go through the motions here. If I had no clue, I could go to the help and scroll down to the bottom to see that 4659, it's flagging acceleration less than or equal to 0. And that drives home the fact that we need to do a warm start for any of those initial values to take place. So in the project control, I can stop it and warm start it. And it looks like I already had that on. So now the jog takes place. And jog forward. That's right, counterclockwise forward when viewed the motor shaft. And we can also jog the virtual. But of course we have nothing to see with the virtual until our next exercise. So in this third phase here of this video, we're going to add another POU, which we'll use in the fast task to monitor the feedback data for the axes. The block that we'll use is called ReadAxisParameters. And ReadAxisParameters will write the data to an axis parameters structure. So var in out to save on data. And that's the PRM element of the screw axis struct data type. Additionally, it's good we know about enumerated types because there's an axis type and you can right-click the help here to see how to spell those enumerated types in order to put the appropriate type for your axis. So once again, I'm going to cut you loose to try to solve this on your own. I will give you a hint, and I'll give you a little preview here. We're going to need the YMotion firmware library. So if you make and get this error, that is what you'll have to do, and I'll lead you through that here after the break. Okay, so we had the monitor POU. And we wanted to run that in the fast task. Program instance of monitor. And I think that should go at the end. We can move these around until monitor's at the end. Now we'll open the monitor POU. And in the edit wizard, the block we're looking for in PLCopen Toolbox is ReadAxisParameters. And let's start with the screw.ref. And the axis parameters will go to screw.prm. That's a structure within a structure. Let's just leave this enabled with a true. And the axis type, let's look at the help for the axis type. It's servo, VFD, stepper, virtual, or external. This one is a servo. Remember, the virtual will be different, and also the external. Copy that one. And then you just double click and paste that over the name of the variable like we've done before. Now param types also in the help is a word. It says used to include additional parameter sets such as camming. And here the param types word and each bit of the word is described. I don't think we need that right about now, so we'll leave that one alone. I'll go on to the virtual also. ReadAxisParameters for the virtual.ref. We got virtual.prm. We'll enable it. And I'll look at the help again. And this one's a virtual, so axis type virtual. Copy. Paste. And we can download these changes. I have an error. And it says here, read multiple parameters is not declared. And the reason is that this block is a singular exception. It's the only block that needs another firmware library. That's why we didn't put it in here to save on the compile space. But we do need it now. So what's required here is to insert the firmware library called YMotion, like we did before in the previous video. And as long as YMotion is in here, now the download will be fine. Now the simplest way to test this in debug mode is to be sure you have your watch window up, and you can look in at the screw.prm, and we're seeing now the update to the actual position or to the virtual PRM element we can see this actual position. Those are kind of buried. Another way to do this is you can add that element directly. Here it is, virtual PRM, add to watch window, and screw PRM, add to watch window. Now I'll go to the HMI here, split my windows. If I jog the screw forward, now the screw.prm, I'm getting forward positions and torques and everything here. So we all got the torque, the position, the velocity, all types of good axis information. And this is another way to monitor the virtual. I can now jog the virtual, and we'll see that the virtual is also jogging. Of course, it knows not to look at the torque, but that's the reason you had that TB axis type. So jog the other way. And so now any of these elements can be used in your code by simply accessing them directly. You could, for example, this one's usually interesting. You could do a greater than, and you could see if the torque of the screw, so you go screw dot parameter dot actual torque. See if the torque is greater than some arbitrary percent torque level. Pretty sure this has got to be an L real. And then you could output some type of torque high output. Let's download that change. And let's look at debug mode. We've got an actual torque there. It's not moving, but it's got some torque. And we could put a level here. Looks like we're in the negative range, negative 2.0. It's 2.0%. And then we can see this logical variable turn on and see how it behaves. Going one direction or the other direction. Or the other direction. So that's the concept and a little refresher of how you'd use those structure elements in your code. So please remember, in this case, the word parameter is not referring to a setting on the servo. It's referring to data. Feedback data is kind of how PLCopen uses that term parameter. And further highlights that you might want to look at, we're not going to do it in this class. There's a product buffer used for latching positions. That's worth looking into. Another one, move relative by time. And we have a whole playlist of tutorial videos. And on YouTube and our website, we do have many different videos that show how to use these blocks like product buffer, move relative by time. And often you'll find even links to those videos within the help of the block. So I hope that this section has convinced you of the power of the toolboxes and that you feel a little more comfortable now with them to use them, putting them into practice and saving yourself valuable programming time.